Hey everyone, we're here with Matt, founder and CEO of BlockNative. He'll be doing a talk on Mempool 101. What you don't know can hurt you. Once he starts talking, can you guys just confirm in the chat that you can hear him?
Hello, everyone. Thanks so much for having me. My name is Matt Cutler. I am founder and CEO of BlockNative, and today we're going to talk about Mempool 101. Okay. I got my first yes, so I'm going to assume everything's good to go. So we'll spend about 25 minutes going through some content and then dive into questions along the way. Please do ask questions in the chat, and I'll get to as many of those as I can at the start. As usual, for anyone who's ever worked with me before, I'm going to move fairly quickly. We have a lot of ground to cover. But this is basically introduction to Mempool and everything you need to know about Mempool in order to get started. We're going to go through 6 primary topics. I'm going to hit on each one of these. I'll recap this at the end. But rather than read this out, let's just get started with the fundamental understanding that all transactions, regardless of type, not just blockchain, but in the fiat world as well, involve incredible complexity. That the nature of transactions is underlying complexity. Every day, we scan our credit cards, we swipe them, we put them in online, and in just a few moments, it gets clear. And I regularly ask people, hey, ever really think about what happens when you swipe your credit card? What's going on while you wait? And 99.99% of people say, no, I never really thought about it. I go, oh, it's actually pretty interesting. Turns out there's at least 6 different commercial entities involved. And here is Visa's 14-step process for confirming a credit card transaction. Now, it's amazing because it's entirely transparent to typical consumers, right? Like all of this amazing things happening in the background, it's happening globally, these fraud checks, these verifications, these merchant checks, the consumer checks, is the card ready to go? And basically this all happens in a few seconds without any awareness from the end user. Now, that didn't always happen that way. It's been decades of innovation that have made that possible. And the same, by the way, is largely true for equity trades. So you can use your favorite traditional stock trading application, buy some Amazon. And this is the flow. This is actually from the SEC of all the various parties who are involved in every single stock transaction. So you have many different entities with many different flows. And I share these two because, hey, we live in the world of blockchain. Here's a very straight interface from Uniswap, right? Seems very straightforward. And when I click transact, I wait a little while. What happens? It turns out a ton of complexity as well. This is a snapshot of the current Ethereum network. This was probably actually from a few weeks ago. But at the time that I took this, there were 8,650 unique nodes that were part of the Ethereum network. And every single one of those is part and party to your transactions in this world. So transactions inherently are complicated, and blockchain transactions are no exception. However, each type of transaction is a different process, different entity, different set of concerns. And so blockchains represent new types of transactions, which represents new sorts of concerns. And that's basically what we're here to talk about today. So when we think about the mempool, there's sort of 8 keys to understand. So when you basically submit a transaction to be confirmed on the network and you wait a while, it actually first goes into the mempool. And the mempool is the sort of staging ground, the cache or the competition where all pending transactions wait and compete for block space. We're going to talk a bunch about this. And there's a bunch of sort of keys to this. Now, when I first started building this, by the way, there's like 5 keys, and then 6 keys, and 7 keys. So now up to 8 keys. I reserve the right to add additional keys to understanding the mempool, but we'll just jump into this because it's good grounding. So the first thing that people find very disorienting about dealing with mempool data is it's by definition pre-consensus. It's the place where transactions go while they wait to be confirmed, as the network basically forms consensus around which transactions to include in the block. Well, so because it's before that happens, it's pre-consensus, which basically means there's no consensus. There's no such thing of consensus in the mempool. There's no canonical mempool. There's no mempool truth. There is just many, many, many unique copies of the mempool, all of which are slightly different, that have slightly different characteristics. So many of the rules that we expect around blockchain transactions do not apply to the mempool. In fact, the opposite rules apply. And again, interesting and disorienting for lots of folks. So as I mentioned, there's no such thing as the mempool. We talk about it as the mempool because it's easier than saying anything else. But in reality, before I showed 8,650 nodes on the network, that means there are 8,650 unique mempools. Each node has its own mempool, and each node's mempool is different than the nodes around it. Sometimes a little bit different, sometimes a lot different, okay? Each node has a set of transactions. Now, if you submit a transaction directly into a node, it inserts it first, it inspects it and inserts it. We'll talk about that. And then it broadcasts it to its peers. And so what basically happens is all the nodes on the network create peering relationships, and they share pending transactions with each other, basically across mempools. And there's all sorts of interesting characteristics and rules that apply to how transactions get propagated through that, which nodes accept which transactions and why. Oh, by the way, nodes can do things like drop transactions and reject transactions that other nodes accept. So when you ask the question, what is the status of my pending transaction? The honest answer is you got to ask 8,650 unique nodes of the network to give you the answer, but you can't, right? You can't actually get access to all of them. So anytime you're figuring out status of pending transaction, it's kind of a best guess about what's going on there. Now, most of the time that guess is pretty good, but under specific network conditions, that guess could be quite inaccurate or bad. So just realize that any node that you operate, any node that you have access to, and even any network of nodes, sort of set of nodes that you have, a cluster of nodes, only have a portion and only have a limited view into all of the transactions that are pending in the mempool at a time. This is very disorienting for folks because they're used to there being one universal truth on the blockchain. That is true. There is one universal truth once things are confirmed, but prior to them being confirmed, there's a whole bunch of weirdness that can happen. Now, significantly, nodes are not, atomic units. They're just computers running software, right? And significantly, that software can be of different client types. Now, the two primary client types on Ethereum today are Geth and Open Ethereum, what was formerly known as Parity, though there are others, right? And those two client types behave differently as it relates to mempool and mempool data. So you actually have some variances between nodes based on which client they're running. And then both of those and all clients can have various configurations. They exist on different classes of hardware with different capacity. They have different settings associated with them. And so how that node is deployed on which hardware with which configurations will also affect how its mempool behaves. And then finally, each node has a set of peers by default. I think the peers are about 20, but they can go up to maybe 100. And those peering relationships actually change quite a bit on the fly. So which transactions you get in what time frame and what order is also a function of the peering relationships your node has on the network. So you have all these degrees of freedom that affect how the mempool actually looks in any one network, any one sort of part of the overall network, right? So again, these things, you think it's a mempool, but it's actually lots of distinct ones, each with their own unique characteristics and behaviors. Now, also, we talk about blockchains being immutable. Mempool is the opposite. Mempool is totally mutable. Any pending transaction in the mempool can be replaced with replacement transaction. These are often known as things like speedups and cancels, though there's often there's other replacement types. And so any transaction which is in there can be overwritten by the originating wallet at any moment, right? And so just because it's pending in a certain state doesn't mean that's the state it's going to wind up at. You can zero it out. That's a cancel. You can add gas to it. That's a speed up. You can actually change any parameters as long as you reuse the nonce and add more gas. So things change underneath you inside the mempool. And oh, by the way, they have all the same characteristics that I mentioned before, where they change across the network, but not all at once and not necessarily consistent. So you can actually have a single transaction which can exist in multiple states inside the mempool simultaneously, which gets kind of fun and interesting when you're trying to figure out what the heck is going on with it. We like to think about the mempool as this inconsistent fabric that is lumpy. meaning you can have areas of the mempool that have one view of the network and areas of the mempool that have a different view of the network. Sometimes those views are geographically based. There's geographic constructs. So you might have nodes in Europe that have a different set of transactions than nodes in China. Maybe it's a little different. Sometimes it's a lot different, right? And this is largely due to conditions of network congestion and mempool pressure. Specifically, as congestion builds and as pressure builds, the fabric gets more and more lumpy. So any one node starts to have a less and less representative view of the entire network during periods of congestion or pressure. And also, that's usually when you need to know the most about what's going on in a transaction, because they're slow, gas prices are high, there's money moving around really quickly, but during congestion and pressure, it can be tricky to figure out what's going on. Effectively, you're going to lob a transaction in, and it's competing for block space. Okay, on Ethereum, block is confirmed every 15 seconds, right? Each block contains typically on the order of 150 transactions. At any given moment, there's between 80 and 100,000 pending transactions across the entire Ethereum network. So literally, every 15 seconds, your transaction is competing to be one of the top 150 against 80 to 200,000 other pending transactions. Seems kind of, I mean, it's amazing it works at all, but that's really the nature of this. There's all these transactions that are competing against each other to get confirmed as quickly as possible for the lowest possible transaction fee, which leads us to our eighth and final key of the mempool, is the competition among transactions determines both gas price and time to confirmation. And so during periods of heavy network congestion, gas prices go up, and it can be harder and harder and harder to get a transaction confirmed. So those are 8 keys you need to know about mempools and how they behave. Now, this gives rise to something that it comes up now and again, but we're beginning to embrace, called the meme pool. So, hey, the meme pool works like this. Traditional transactions, whether they're credit card transactions or equities, sort of this like very formal, very stuffy, very standard dance, right? A waltz or ballroom dance. Everybody knows the rules. Everybody plays by the rules. It's all very orderly, right? We like to think about blockchain transactions as a little bit more spontaneous, more like a flash mob or square dancing maybe, right? Where people jump in and they do their thing and it's all sort of natural and organic and it's not nearly as stuffy. But what really is happening is it's really more like a mosh pit. That you have all these transactions in the mempool which are competing against each other for confirmation. And they're not just sort of lightly doing this in this orchestrated fashion. They're colliding with each other. They're competing with each other. And oftentimes they're actually trying to harm each other in this world. And so, hey, look, if you expect a flash mob but end up in a mosh pit, you're going to have a bad time. And then similarly, if you expect consistent blockchain transaction behavior, you're going to have a bad time because network conditions are constantly changing, and this adversely impacts transaction behavior. And what it does is it creates unpredictability. And so this is why we feel this subject's so important for everybody in the space and why we want everyone to be on the same page in terms of Mempool 101. Because if you walk in with one set of consistencies, it's this really nice thing that's going to be really cleverly organized and everyone's going to play nice with each other, you're going to have a bad time because that's not at all what's happening. Because there's transaction risk at every stage of the game. Now, typically what happens, let's just say we're going to do some transaction settlement, an institution or yourself, you initiate a transaction, you wait a little while, and it settles. What happens while you're waiting a while? Turns out a whole bunch of stuff. Your wallet composes and transmit the transaction. It enters into a gateway's mempool once it's been inspected. That gateway or that mempool, that node then transmits it to its peers. It enters into mining pools. So not all the nodes on the network are miner operations, basically trying to confirm transactions. So it's a portion of the total network, which is mining. The miners create candidate block templates. They basically create the block they're trying to solve for, and then they start to put a whole bunch of computing power against that. One of the computers has a winning block, has the constants that they need, and they add that to the chain and transmit it, and then ultimately that gets accepted and settled, right? Seems pretty straightforward. Well, there's actually a whole bunch of steps here, and as you might expect, every one of these steps introduces non-zero risk to your transaction. It can be canceled, the wallet can fail to transmit, the gateway can fail to accept, or the gateway could be isolated. The network could be congested. The nodes, the peers that the gateway that is transmitting with could not be ready to accept it. The node could drop your transaction. It could get stuck due to non-scaps. Your transaction can get front run, so people can detect it because the mempool is public. And basically based on that, conduct transactions in front of you with more gas to try to leech profits from you. They can backrun Oracle transactions, try to get transactions in right after an Oracle updates, and you can just be outcompeted by something with a higher transaction fee who's watching what you're doing and just always one step ahead because they can see what's happening to your transaction while it's pending. Hey, a miner could do something like inject invalid blocks, or you could have all sorts of games miners can potentially play. You could be part of a winning block and say, hey, my transaction got confirmed, and then it could get replaced or reorganized and get unconfirmed, if you know what I mean. And so all of these things wind up creating this tendency for the mempool to be considered a dark forest, okay? It's this place which isn't very friendly, which isn't very easy to navigate, which is full of apex predators who are coming after your transactions. Now, the notion of a dark forest is from the science fiction series by Xijin Liu. It started with the three-body problem, but basically the dark forest says the reason why we don't hear from alien species is not that they're not out there, but that the universe is a hostile place, and that all of the smart civilizations understand that, and they stay silent because as soon as a new civilization is detected, basically adversarial civilizations show up to attack and exterminate. Okay, so the dark forest it's full of life, but it's silent because everybody's hunting everybody else, and this seems to be true of the mempool in Ethereum in particular. This was really started by this great piece by Dan Robertson called Ethereum as a Dark Forest, where he gives a pretty compelling narrative about some experiences that he's had with trying to get transactions through in an undetected fashion, and bots basically determining what he's doing, front running it, and stealing funds. He's not the only one. You have many great narratives out there today, like Staring into the Monster's Eye, right? Learning about this is Alec Minushkin. And then you have How to Munch on Pickles from a Whale Dinner, which I love the title of that one, but also a very similar set of activities around how to, the descriptions of how to make profits when large transactions are occurring. We at BlockNative published this post about evidence of mempool manipulation on Black Thursday, and these new things like hammer bots and mempool compression, and how that adversely impacted how various transactions were propagated and behaved during Black Thursday. And then recently, Sam Zun published Escaping the Dark Forest, which is great as well. And every single week, more of these accounts seem to come out, which is both great for raising awareness, but also pretty eye-opening in terms of what's happening out there. And so at the end of the day, all transactions have complexity. Complexity brings with it transaction risk, right? So it doesn't matter what type of transaction you're doing, whether it's a credit card, equities trade, or blockchain transaction, they carry with it non-zero risk. And in these existing worlds of transactions, you have entities whose job it is to deal with and manage and mitigate transaction risk. But today in blockchain, that hasn't really emerged as a thing yet. But this is basically why we do what we do, is to help folks like yourself understand what the risks are and begin to manage and deal with them. Okay. So what we do is we have this global infrastructure that connects to the network in as many places as possible, and basically provides a holistic view of the global mempool, so you don't have to build that yourself, and then basically makes this available on a programmatic basis so you can monitor your transactions and intervene into your transactions when necessary. And so that's why we do what we do, and that's why we talk about this stuff. So our objective is to help you master the mempool, be on top of all of these things that are going on, so you can be aware of both how your transactions are behaving. You can be aware of how protocols are being used. You can be aware of these front-running apex predators who are trying to leech profits from you, and you can do the right thing. So you can construct your transactions in such a way that they're going to complete the way that you expect, when they run into difficulties, it's not if, but when they run into difficulties, you can intervene, and you won't deal with things like stuck wallets. You won't deal with things like massive frustration when, Uniswap introduces its token, network prices go, gas prices go up. You're trying to figure out what the hell's going on. You're trying to submit transactions. They're stuck. Your wallet's not working. You're going through Etherscan. You're not really sure what's going on. Basically, all of that pain and frustration is due to the issues we've already talked about. And by having visibility into mempool data, will give you tremendous degrees of confidence moving forward. And so we really feel that everybody in the space needs to be aware of these issues and needs to basically be working with mempool data as part of their day-to-day operations in order to not have a bad time. So we have this new offering that just came out called Mempool Explorer, which basically is a front-end visual interface for authoring data streams. You can get started for free. It's explorer.blocknative.com. I recommend you check it out. But basically this whole idea here is, this dark forest isn't great. It's not great for you. It's not great for the protocols. It's not great for the exchanges. And quite frankly, it's not great for the ecosystem. That to the extent that Ethereum and the mempool is this dangerous dark forest, we believe that's going to suppress new user adoption. That's going to prevent people from fully embracing the promise of blockchain technology because it's just too hard to navigate. It's too weird. It's too dangerous, right? And so what we really believe the case is by adding a little bit of light here, we can begin to illuminate the dark forest. And the more light that we're able to shine and the more facile that members of the ecosystem are able to become with mempool data, the happier and better everybody is going to be, because the transactions will be lower risk, the results will be what people expect, and we'll be able to move forward in a much more sort of organized, coherent way, as opposed to an unpredictable, not resilient, not reliable way. And so that's really what this is all about. It's just eliminating the dark forest, making it a bright forest instead. So hundreds of projects today in production are using our stuff. Here's a bunch of ones who rely on us. And later today, I think in an hour or two, I'll be giving another session focused on mempool primitives. So this is Mempool 101. That's going to be a little bit more sophisticated, talking about sort of the basic building blocks that are emerging for dealing with mempool data. So that's what we talked about today. Transactions are fundamentally complex. There are at least 8 keys to understanding, quote unquote, the mempool. The meme pool helps people understand. Remember, if you show up for a flash mob and you're in a mosh pit, you're going to have a bad time. The same is true of blockchain transactions. You really got to understand that the mempool is a mosh pit, and you need tooling and monitoring and observation to make sure your transactions progress smoothly. You face non-zero transaction risk. It's a dark forest, and we're creating tools to help you deal with that. So I'm just over 20 minutes. I'm actually pretty excited about that. We went fairly quickly, as I tend to do, but we have a little bit of time for Q&A if folks have questions out there. And so I see at least one question on the chat. By all means, put more in. And the first is, so what stops this from becoming the bigger big brother? Which is a really great question. So something about that's important to know about public blockchains is they are by definition public. Okay, everybody can see what everybody else is doing. Now, you don't really know who's who, but you can see all the addresses, right? This is one of the great characteristics of blockchains. They're transparent, right? The same is kind of true of the mempool, but not entirely, okay? So the mempool is also, quote unquote, publicly available, meaning anyone can operate a node. The node has a mempool. You can inspect the mempool and see what's happening. But mempool data is exceptionally difficult to work with. And it's very difficult to get a global perspective of the mempool. And so what we're finding, how these apex predators in the mempool tend to work, is via information asymmetry. You basically have actors in the marketplace who have superior mempool information, generally built themselves, and you have regular folks who don't have access to that, and they're at an information disadvantage. So what we believe is sort of the opportunity here is to democratize access to this data, to make it so that everybody in the ecosystem has equal access to mempool data and equal facility for working with them. We think this will have the net effect of leveling the playing field. And generally, when it comes to financial systems, more transparency is better than less transparency. There are many privacy-preserving L2s that are coming up, things like optimistic rollups and ZK rollups, stuff like that, which are sort of independent of this. You can still see those transactions happening. You just can't look inside of them. And so overall, we think this is a really important point to get to, which is universal access to mempool data and access to tooling to work with it effectively. So we don't have a condition of have and have nots. We have something where everybody has the benefit of mempool data for their transactions. Okay. So I see a question right here, and I'm just going to read these as fast as I can. Are you expanding the BlockNative offering to other chains? Is mempool data simpler by construct for these chains? So today, I appreciate the question. We support Ethereum and Bitcoin. We support all mainnet and all testnets on them as well. Bitcoin's actually quite a bit simpler in terms of its mempool, largely because there's just only one type of Bitcoin transaction. And so generally smart contract blockchains are going to be significantly more complex in terms of their mempool mechanics than UTXO models, for instance. But generally, any smart contract platform is going to be pretty intricate in terms of what's possible, because the transactions that are in the mempool can be arbitrary. They can do anything. Ethereum's Turing complete. So being able to make sense of what a given transaction is trying to do is vastly more complex in a smart contract platform versus a UTXO's platform. Every single blockchain has different characteristics associated with it, but most of the ones that people are talking about now and really paying attention to are leaning towards smart contract platforms, which means they're relatively intricate and complex to work with. Okay. What do you think about the emerging trends of miners offering private access to submit transactions to their pool of pending transactions, so you don't have to broadcast your transactions globally? So this is something which is brand new. That's a great question. And this is part of what is generally known as a field called MEV, or miner extractable value, where you could say, hey, Mr. Mining Pool, I don't want people to know what I'm doing, so I'm going to give my transaction directly to you and not broadcast it, and then you're going to stuff it into a transaction. Now, stuff it into a block. This is interesting and problematic. It's problematic because now you have mining pools who can exert undue influence on what happens on the chain. In particular, miners could not only insert transactions into blocks, they could suppress other transactions from getting into blocks. Specifically, a miner is doing some of these, hypothetically, a hypothetical miner is doing some of these techniques that we talked about, and they see a particularly profitable trade or arbitrage opportunity. Why should they let it go by? Shouldn't they just block that, suppress, censor that transaction, and put their own transaction, does exactly the same thing, and get that profit, right? And so we think this is a kind of a slippery slope, where only under exceptional circumstances should transactions not be public, because this then creates all the conditions to sort of undermine the egalitarian equal access notion of blockchains. So now imagine we enter into a world where to really get a transaction on chain, you got to have a private relationship with a miner, and you got to pay for that. Well, who's going to pay the most? The ones with the biggest pockets, right? So I think this is a little bit concerning. Now, on a side note, we're doing some research right now, but our data would seem to suggest that about 1% of all transactions have these characteristics. About 1% of all Ethereum transactions don't ever hit the mempool. They just appear on chain. Now, it turns out that 1% is almost entirely a very specific class of transaction that is probably not that concerning, but there are certainly other transactions which appear to just spontaneously show up on the chain and never having been detected across at least any of our mempools, and we have pretty close to 100% access. So there's all sorts of interesting challenges here, and I think that's something that we're going to need to pay a lot of attention to, specifically as you have mining pools that have a lot of the hash power of the whole chain. You can really create some interesting challenges in terms of the network security that we all rely on Ethereum and any blockchain for that matter. Okay, that was a lot on that one. How far can BlockNative tools help me if I'm on the losing end of a transaction? Will I be able to cancel a transaction if I'm being front run? Yes, exactly. So our tools are really designed to provide all of the monitoring that's going on around your transaction. So you can detect things like front run behavior so that you can then say, you know what, I decided not to do that, which by the way is a pretty interesting thing. If enough users put transactions out, detect front running, and cancel, then front running can become a lot less profitable, because you're going to front run a transaction that didn't happen. There's no profits to be made there. In fact, there's probably losses. And so we think that this is something that's going to be pretty interesting as we start to see more democratic access to this data and to this tooling to create a more level playing field across the board. There's a ton more questions coming in, which I greatly appreciate. I'm sorry I didn't get a chance to get to all of them, but we're right at 1:30 and I want to respect the next speaker's time. So I just want to thank everybody for joining me for Mempool 101. I have another session on Mempool primitives coming up in a little bit.
Awesome. Thanks, Matt. This was really great. So our next talk is on MEVs. So join us. Thanks so much.